Yeah, well, start by thanking Susan and the LMC for inviting me to speak today. Going to be talking a little bit about a telemetry study we've been working on for a few years here, focused on understanding the efficacy of the Northern Refuge. So we actually just downloaded the last of the receivers in September, and so the results are kind of hot off the press here. We were working diligently this week to get these to you. So just kind of see them in the light of them being kind of preliminary. We're going to still work on this, but we have seen some really interesting trends so far. So why are we doing this? Basically, refuges have been used in Lake Superior, Huron, and Michigan since the late 1970s as a tool for helping to enhance the recovery of lake trout by protecting them from fisheries exploitation. The refuge in question today, the Northern Refuge, which is shown here outlined in black, was established in 1985, covers an area of about 2,300 square kilometers, and includes several known historically important spawning reefs. And this area has been consistently stocked since the refuge was established. But despite the stocking efforts, as well as sea lamprey control, there's really been very little evidence of natural recruitment in the area. And this lack of measurable recruitment has led some to question the utility of the refuge. So that's where this study comes in. The overall goal of the study was to determine to what extent the Northern Refuge protects lake trout from fisheries exploitation. And to do that, we came up with 4 objectives. I'm only going to talk about 3, the 3 that are highlighted today, just in the interest of time. The first was to determine what portion of the Northern Refuge lake trout are leaving the refuge each year and for how long. Objective 2 was to determine if the Northern Refuge lake trout display seasonality in their refuge residency. And the 4th objective was to determine if the degree of refuge residency differs among spawning locations and is predictable based on the proximity of those locations to the refuge boundary. So I'll just be really brief here with the methods. We did deploy an 80 receiver grid within and around the border of the of the refuge. And then supplemental to that, there are also several other larger grid arrays that are maintained for other projects within the GLaDOS network. Most notably, one here for whitefish and ciscos, and one on the other side of the lake, primarily used for looking at whitefish movements. We deployed those receivers first in 2021, and they stayed in the water until 2025. In fact, they're still in the water in support of other projects, but that's kind of the end of this project. For tagging, we tagged in 2021 and 2022, and we tagged a total of 209 adult lake trout at 4 known spawning locations, and the tags were split as equally as we could make it between the 4 spawning locations. Those locations were Gull Island Shoal, Boulder Reef, Middle Ground, and Big Reef. And then we tracked those fish between 2021 and summer of 2025. So this is what we saw here. This graph shows the refuge residency of individual fish after we had to do some filtering of the data to remove fish that had died. With the black dots indicate that the fish was determined to be within the refuge, and the spaces between, they were determined to be outside of the refuge. And then we overlaid this on top of a background that indicated which season. And these seasons were based more on thermal profiles than on calendar dates. So pretty busy graph, but there's really 2 take-homes here. The first is that every single fish left the array, but the amount of time that they left the array for varied quite a bit between individuals. But also there was a clear pattern of seasonality, with fish tending to reside in the array more in the summer and fall than in the winter and spring. Focusing a little bit more on that seasonality, these graphs show the seasonal refuge occupancy. So this is the mean refuge occupancy of all the fish. Each of those bars represents a 5-day window, and the height of the bar is the mean refuge residency. And then each bar is color-coded based on the season. So we'll focus just on the 3 years that we had a complete year of data, 2023, 22, 23, and 24. And again, there's a couple really obvious things going on here. The first is that you can see, if you look between the orange and this is actually blue, but most of the fish leave the refuge right after spawning. So we see huge emigration from the refuge right after spawning. And then the fish tend to return to the refuge a little bit more slowly in the spring. And then that results in higher refuge residency during the summer and fall seasons. The other way to look at this, we've just got some summary information down here. We look to see what percent of the fish were spending more than 50% of their time in the refuge based on season. And the results mirrored what you'd expect. In the winter and spring, we saw only about 15% of the fish spending more than 50% of their time in the refuge, where in the summer and the fall, it was between 40 and 45%. Breaking that down now by the individual tagging locations. Again, this graph shows the trend that we keep seeing. We did see about twice as much refuge residency in their summer and fall months compared to winter and spring. The trend was similar across spawning locations, with the exception of Gull Island, which had significantly higher summer residency than the other 3 locations. So just kind of the take homes from this, we did see that all the fish left the refuge, but the duration of residency outside the refuge did vary significantly between individuals. Most of the fish left immediately after spawning, and then many returned to the refuge in the spring, and then seemed to spend summer and fall in the refuge. And there were seasonal patterns that were very obvious, and they tended to be similar across the tagging locations, with the exception that we did see higher summer residency with the gull and shoalfish. But that is not what you would have predicted based on proximity, because gull and shoal is kind of in the middle of the array. So our hypothesis that you'd be more likely to leave the array if you were spawning close to the edge of the array proved not to be true. So moving forward, we're continuing this analysis. We've actually just brought on a postdoc to help us with this, and he's the one that produced all these great graphs. And we're hoping to be in a position to provide kind of like a final report at the LMTC meeting in the summer. So with that, I will take any questions.